Okay, I'm Jeongsik from NCSoft, a gaming company in Korea. Today I'm together with my colleagues Jeongsik and Juno here, and we work at infrastructure division. Today I'm going to introduce our first experience of adopting container and Kubernetes technology for some of our game services. Okay. I don't know how much information you have about Korean games, but Korea has the fourth largest gaming market in the world. And NCSoft is providing very popular MMORPG PC games mostly for about 20 years now. And we're also providing game services in the US, UK, and other countries too. Our infrastructure are mostly based on on-premise physical machines and virtual machines. And our server applications have been optimized for many years. The infrastructure team also optimized our servers and network for the game services too. And we also know the traffic patterns, weekly, daily, hourly. So in short, I can say that our infrastructure and operation has been quite stable. But we got a challenge that started from a few years ago, it's from mobile games. The mobile game market is growing very fast. So NCSoft is also beginning mobile game business. But mobile games are quite different from PC games. The life cycle is very shorter than PC games. The second chart shows that half of mobile games or mobile apps lose half of their peak users just within 3 months. And the workload of mobile game are much more dynamic. So for mobile games, we infrastructure team should be ready for more new game service launches and more frequent service updates or release. And we should be also more ready for more dynamic workloads. So I think it's a big challenge for us. So our approach to handle this is adopting hybrid cloud and container technology. With hybrid cloud, we are going to provide infrastructure for mobile game services. For the static portion of the workload, we prefer using private cloud because we believe it is more cost efficient in the long time. And for the dynamic portion of the workload, we use AWS and Google Cloud. Like many other companies, our choice for the private cloud is OpenStack. But hybrid cloud is nice, but there is one problem. The operation can be very complex because there are various operation tools from multiple providers, and service configuration and deployment should be customized for each environment. And here we believe container and Kubernetes can reduce the complexity. If you containerize an application, you can deploy it anywhere. With Kubernetes, you can manage the containerized services more consistently over multiple kinds of infrastructure. There are a few available orchestration tools, but we prefer Kubernetes because it is very active open source project, evolving very fast, and we especially like the way of service configuration of management of Kubernetes. It's very well organized and easy to manage, I think. So we set up our first Kubernetes over OpenStack. And many people ask why Kubernetes over OpenStack. my boss asked me this, and I have two answers for this. One, OpenStack is just one of them, because we are going to provide container clusters over multiple infrastructure. So we will expand it over Google, AWS, or bare metals later. Secondly, we think the combination of Kubernetes and OpenStack is nice. With OpenStack, you can provision compute, storage, and network. With Kubernetes, you can provision services. So again, the combination is very nice for the whole operation. And here, I'd like to share some our technical discussions we had during the configuration of our Kubernetes over OpenStack. I'm not sure how much it would be interesting to you, but still, let me share. If you set up Kubernetes over physical machines, each node is actually a physical load, right? So each node will have guaranteed capacity as the capacity of hardware. But if you set up Kubernetes over OpenStack, each node is virtual machine. And a virtual machine may have less capacity if there is very busy noisy neighbor together with over a same physical machine. But Kubernetes scheduler does not consider the real capacity of each node when it does the pod scheduling. So that means some pods may be deployed to a Kubernetes node which does not have vast capacity at that time. So question is, do we need to handle this situation or not? So one way is that just keeping it as it is, and then you monitor the usage of each node and do the scaling of the nodes as needed. Actually, we are doing like this. We are actually implementing now auto-scaling using OpenStack API. Or if you want guaranteed capacity for each node, Kubernetes node, you may do some dedications. You can dedicate physical machines only for Kubernetes nodes, or you can dedicate the same number of physical cores for each Kubernetes node. Okay. And second thing was about networking option. Actually, at first, for the Kubernetes, we just used the default networking option, Flannel VXLAN, for the Kubernetes networking. But we found that the bandwidth was not so good in our environment. And we got a good tip from a Google engineer that we can use another option, host gateway. And we found that the bandwidth is nice, like other cases. So we are using it. But later, we also found that we can enhance the bandwidth of VXLAN by changing the value of MTU, maximum transfer unit, like this. So the learning we got here is that we need tests like this when you set up Kubernetes over cloud infrastructure. Okay. So we set up our Kubernetes like that, and it's time to migrate some existing services. Usually a game service consists of multiple smaller services, including login service, lobby service, world service, like that. And there are also platform services which provide common functionality for all the game services. But it is not practically possible to containerize all of them. In our case, some services are running in Windows OS, and some services are stateful and non-scalable by design. For example, game world, each world has a its unique concept and different data, unique data. So and also it's non-scalable by design. So we tried to find stateless and Linux-based services for our migration. And we found 16 such services for our first migration. And we worked with the service development team and gave some guides so that they can adjust their build and deployment system according to Kubernetes environment. And also we wanted to finish our first migration without any problem so that we can invite more customer of our new environment later. So initially we just kept the previous old virtual machines as they were, and we added each Kubernetes node to the existing node balancer using node port option. And then we monitored them to verify that the new Kubernetes side handles services as expected. Then we removed the old virtual machines. So the migration was smooth, no service stop. So result, resource saving. The total volume was not big, but I think the gap is quite big here. And I think the resource saving is not from the technology change, actually. I think it's from the change of concept or work process. Before Kubernetes environment, each service team requested some number of virtual machines to infrastructure team. But the real average usage is not so high, right? But in Kubernetes environment, there is no concept of machine in service layer. There is just service and pod. And it is very easy to scale out. They are doing scale out by themselves very easily. So they do not request as much resource as before. And as I mentioned, the scale out process is very simple. Before we had to create a new virtual machine, install application, and add the virtual machine to load balancing group. Some steps may require manual process, right? So multiple steps. But now it's just one step, one CLI command, kubectl scale. Or you don't need any step if you use auto scale option. So it's very good for operation. Okay, so now logging and monitoring. I think logging and monitoring are mandatory systems for service operation. So let me share our configuration for those systems. If you are going to migrate some existing services, there may be many kinds of log files. Some files are custom log files from applications. So we try to find our best handling way for the log files. And the two questions we got are first, the location of log agent, in our case, FluentD. Second question, the location of log files. And about the location of log agent, there are some options. You may put an agent in each container, or you can put it in each pod or in each node. In our case, we decided to put each agent for each pod, like this slide. You can see that each pod has its own FluentD as a separate container. And all other application containers write log files in a directory, which is provided using empty volume. And empty volume is accessible from all the containers in a pod. So FluentD container can read all log files, can send them to the Elasticsearch. So I think it's kind of a scalable way for the handling of log files. Okay. monitoring. We have been using Jeongsik for our infrastructure monitoring. And for Kubernetes monitoring, at first we tried to write some custom scripts. It collects Bayesian metrics using Kubernetes and Docker APIs. But we soon found out that Prometheus provides much better monitoring features. So we are now using Jeongsik and Prometheus together. And also we are using Grafana for the integrated dashboard so that we can see all the infrastructure metrics from Jeongsik and Kubernetes metrics from Prometheus in a single page. Okay, next step. As you saw, our first migration was not so big, and it was partial. And now we are working with a game development team. They are developing new mobile game, which is fully containerized and stateless, scalable, and Linux-based. And they are going to launch this service in Kubernetes environment soon over OpenStack or AWS. So I hope that we can share that experience too soon. Okay. So this is last slide. As I mentioned earlier, sorry, there is complexity problem with hybrid cloud. So we have our own integrated provisioning system to reduce the complexity. Our current system provides our own standard API and UI to manage the IaaS layer consistently. And now we are adding features to manage Kubernetes clusters and nodes. And also we are going to add features to deploy application binaries or container images. So I hope that we can have a really integrated provisioning system from IaaS layer to the service layer. Okay, that's all I have prepared for today. I hope that this was informative for you. Thank you. So, if you have any questions?
So you're running Kubernetes on top of OpenStack. Are you using Magnum or any of the other frameworks there, or is it something you manually do?
Actually, we are not using Magnum or any OpenStack related solution. We are actually we prepare using pure independent solution because we are going to provide Kubernetes cluster over multiple kinds of infrastructure. Okay.
So, did you do any testing around Kubernetes, like running it on per node versus in every single pod?
Sorry, the testing about.
So, was there a reason why you didn't run FluentD as a
FluentD?
Yeah, FluentD.
Yeah.
So, is there a reason why you didn't run it as a daemon set instead of having it in every single pod?
I see. So your question is why we put an agent for each pod instead of node?
Correct. Yeah.
Because each service has its own custom log files, so we need to put some parsing rules for each service. So I think it's better for the service development team to handle the parsing part for FluentD for each service. So that's why we set up like this. Okay. Okay.
I have a question about the FluentD. So you're running more than one process in a pod. Where are you using the supervisor? How are you managing two applications in a single pod? Or are they multiple pods for FluentD in your web application? So so if FluentD dies, what happens to the pod?
FluentD dies.
If FluentD crashes, does the pod restart or does nothing happen?
I'm not sure that part. said the pod will start if process in a pod crashes.
Sure. No, it's fine. And I apologize for asking.
Okay. Any other?
So, when you spin up VM, which Linux distribution do you use, like CoreOS or Ubuntu or
CoreOS.
yeah, the Linux OS distribution? Which like use Red Hat or Huawei?
Which one?
Core OS.
Ubuntu? Sorry. Actually, I'm not a hands-on engineer, so because that's why I'm here with my colleagues here. Which one? He said we are using Ubuntu.
Using what?
Ubuntu. Okay.
So, the mean that like I heard small blog like a lot of people using Docker container. Did you use Docker container?
Sure.
Okay. Did you find any kind of stability issue when you put some kind of a long running processes to Docker container? Because some of blog saying that Docker is regularly kind of crashed out.
Actually, we didn't find such issues yet. We have been operating this cluster now about 4 or 5 months, and no issues yet like that.
How has debugging changed in the new environment versus what you were doing in the old environment?
That's a good question, actually. But debugging means the service debugging, right? Yeah. I don't have many information about that yet, but now I think each development team is handling each service by themselves more than before. So we do not know how they changed the debugging process with this. But in infrastructure layer, we are only focusing on the Kubernetes cluster itself, node itself. So I think it's more separated. Yeah.
Do you have any performance metrics or numbers, having running over 4 months, any sort of outcomes?
Performance metrics about
How much load those APMs you have on the container can support?
yeah, actually the average usage of the node is not so high yet. Actually, we started with 16 services, I said, but now we have about 30 services over 13 Kubernetes nodes, which is virtual machines. But actually, as I mentioned, the main the game servers not migrated yet, so the usage is not so high yet. Okay. Thank you very much.